Hi everyone, David Maley here, and today we're going to do sentimental analysis. This is really cool. We're going to look at online sentiment using Twitter for a grocery store chain out in the West Coast. So what I want to do here is I'm going to start off with library stuff, but what I want you to be able to end up with here is really cool. You'll be able to measure customer online sentiment in negative and positive, and be able to measure that. So you'll be able to end up with something like this here, where you can see this was majority positive, some negative, and I'll show you how this comes out so you can see what the words are and how a store or a company or whatever you're looking at rates in a negative and positive manner online. So I'm not going to scrape the data from Twitter on here. There's many ways to do it. You can go pay someone to do it. You can use a Twitter API to get the data. You can also manually do it if you don't have that. There's numerous ways to do it. I'm not going to go about that in this video. Maybe I'll do it in another video. But in this video, we're going to assume you already have the data from Twitter. Okay, and then you just need to go and cleanse that data. You need to remove things like usernames and junk pieces like comments and words that aren't going to be a part. You want the actual replies. Okay, so anyway, let's get started here. So on the sentiment analysis, we're going to load in these libraries right here. Tidy text, text data. Oh, look at that. I've got tidy text in there twice. We really want that one in there, don't we? Let's get rid of that second one. All right, so tidy text, text data, read Excel, because I'm reading an Excel sheet. Deployer, DPLYR, stringer, tibble, it's late at night, sorry. Tibble and ggplot2. Those are the libraries we're going to load in. Then what we're going to do is we're going to bring in not one, but three different libraries or dictionaries on sentiments, right? So they all contain different groupings of sentiments of words and how they're negative or positive or ratings based on them and stuff like that. So one is AFIN, the other one is Bing, and the other one is NRC. So we just put gets_sentiments, we bring those in. Then I'm going to bring in the data. In this case, I want to be able to manually choose my data, right? So I just put this read XLSX_XLSX, which is from that library I showed you above, file.choose, just this. When you run that, it's going to pull up a little window so you can go and look at your files and figure out where it is. In this case, I already have it, and it's right here. Okay, so these are all the very different things we have for people for this, and what they said, all their replies and stuff. So I know I have that, and it's all one row per reply, right? And well, some replies could have more. It's possible in there. Anyway, so what we need to do is we need to take that. Remember, you saw that where replies have multiple words to them: Mo, purple heart, Trump heart, jerk chicken, Trump rolls, Virgie. Some of these have single words like Trump. Some of them have what's the date, funk the shenanigan, whatever. It could be anything, right? But what we want to do is we want to put them one word per row, right? So how do we do that? This right here. So what we're going to do is we're going to say we put this file into data 2, right? So now it's in data 2. And then what we want to do is we want to pipe data 2 into mutate, right? That's what this is right here. This is the pipe function. By line number equals row number, right? And then we're going to pipe that into unnest tokens word comma text. So what that means is I'm going to go and get a word for each row. So if a reply had 5 words in it, I'm going to have 5 rows. That's how that's going to work. Okay, and then just make sure in your data that the column of your replies has text at the top of it, or change this to be what it is. So if I go back here and I go all the way to the top, see that? That one's got to say whatever that was right here. Okay? So if I call that words, then that would have to have words in the top of the other one. If you don't, it won't read it. Okay? So you run this. This will read it by word. Okay? Then what we're going to do is we're going to say, okay, I need to have, because I know there's words that are nonsensical. Nonsensical means stop words, right? Things that don't count. So I, is that negative? Is that positive? Just I, right? C, S-E-E, S-E-A, C, Do those mean negative, positive? C could be positive, but I doubt it. So you want to remove those things. So what we have is there's a data dictionary called stop words, right? And we're going to pull that in. It's from the tidy text package that we put in above. And so if you run data stop words, that brings that in. But now keep in mind that stop words, that doesn't remove curse words. Remember, so we can't go and give something like this to an executive, right? And say, oh, here's your, and have all kinds of curse words in it. So, you know, people online, they say all kinds of stuff. We got to remove that stuff. So we're also going to have to create a little process here to remove the curse words. So what we do is we create two variables, A and B, and we put in A all the actual curse words that we think we're going to run into. I'm not going to repeat them here, but they're right up above here. And then each one is a curse, 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 curse. See that for each one. Okay, and the reason why we're doing that is in stop words, if you were to look at stop words, you'd see that they has two columns that we need to have data for, not just the actual curse words. So what we do is we then take that data A, comma B, and we put that into a data frame. See, that's what data.frame does, and we put that into curse words. See that? So now we have curse underscore words and we have stop underscore words. Now what we need to do is we know that in stop words, if we were to look at that, we have two columns, word and lexicon. Word is the actual word itself. In this case, it would be the curse word, right? And then lexicon, which would be this. What is it? It is a curse. So in this case, so we would want to put C, word, comma, lexicon, right? And put that into call names, because we're changing the call names of curse words, right? Then we need to append that back to stop words, right? So we do that right here. R bind stop words, comma, curse words. We put that into stop words, right? Because it goes back to stop words. Now our stop words will have all of the curse words in it along with the stop words. That's what that just did. Now, once you've done that, we have this thing called stop words, but we haven't applied that to our data yet. So we need to do that. So now that's where we're going to actually remove the stop words, right? So if we do this, let's take a look at this. We've got data by word, right? Which is what? Data by word is what we created above, right? Where it's data by word. That's why I called it that. Very simple. And we're going to put that into cleansed data, okay? Then what we're going to do is we're going to take cleansed data and pipe that into anti-join stop words. So we're going to put that in there, and that puts that back into the cleansed data, okay? So now it has the anti-join. The anti-join is the negative. So what that means is I don't want the stop words in there. If I put join, that would be I want them in there. I don't want them in there. So I want them removed. So it's going to remove all of the stop words, which also includes the curse words, right, from the cleansed data. Then once we're done with that, we want to go and look at and count the or show the top 10 default common words, right? So if I take this right here, what this is doing is I'm taking cleansed data and I'm piping it into count word sort equals true. Let's see what that does. Watch. If I click on that, 1 through 10, tells you right there, it's a tibble, word, and it tells you, the word and then how many times. Safeway, replying, mask, store, Trump, I'm, LOL, people, tears, food, and it tells you how many times they all show in those replies. Okay. Then if we go down here, we want to graph the most common words, right? I want to see, how often these words show. So let's take a look at that. Here we go. From Safeway, replying, store, mask, Trump, all the way on down to, grocery, don't, stores, mask, floor, California, assume CA is California, and Biden. Okay, and that's how it works there. That's not to put a political spin on this. I'm not doing that. It's just that's the way the data is. By the way, I didn't show you up above. This is data from October 1st to October 12th of this year for a grocery store chain out in California. So next, based on this data, if we graph the most common words without the top ones, right? We don't want Safeway in it. We don't want replying in it, okay? We want the rest. So let's take that. What happens if we graph the most common words with those two taken out, right? Let's do this thing again. And here we go. We've got store, mask, Trump, tears, all in the top 5. And the bottom 5 are stores, masks, floor, California, and Biden at the bottom. I think there's a tie really between stores, mass, floor, California, and Biden, but that's just the way it is. So if we look at this, now if we create the word cloud, so word clouds where you saw that earlier, that was positive, negative. This is before that. We're just going to do a word cloud on the most popular words, right? So let's do that. Actually, hold on. Before we do that, let me just go over some of this, what we did here. We did show you the cleansed data. I didn't really go into this of the most common words, what we're actually doing here. So let me go back over this. I'm going a little too fast for myself. It's late at night. So let's go back over this. So let me show you the data here that we're looking at. So we got cleansed data, right? And what we're doing is we're piping in a lot of pipes here. And what we're doing is putting in the count, word sort equals true, right? We want to know how many. Then we're putting in a filter of n greater than 13, right? And you could have picked anything you want. It doesn't matter. It depends on how many replies you have and words, and how many you want to show here. In this case, I wanted to show this many. So that's where I put n greater than 13. Mutate word equals reorder of the word and comma n. And then ggplot aesthetics word comma n, which is where we put this in here. And column, geom column of X lab and Y lab, which are your, your X label and your Y label, and coordinate flip. And then what happens is when you do that down below, you just put in, because you can't put in the title in this, you've overloaded it, so you have to put P plus GG title of most popular words. That puts the title up there. Okay, if I try to put that in there, it doesn't necessarily work all the time. I've overloaded with too much stuff in there already. So that's why I'm piping that into a P, and then I bring that back plus GG title. Okay, you've seen that. If you want to see more about advanced ways of doing graphs like this, I've got some other great videos that go into much more depth than this. So next, you'll see we're doing basically a lot of the same stuff. Same thing here, piping it into P. We're putting, count, but this time we're removing Safeway and replying from it. So if we run this one, it's the same thing, except we remove those two. See that? That's all. It's the same thing as the one above it, just removing, see right here. So instead of just n greater than 13, we also put word not equal to Safeway, word not equal to replying. Okay? Then down below, so now that you know how to do those, let's create the word cloud based on the most popular words. It's a little bit different. So we bring in this library called word cloud, right? In R, this is what the library is. And then you're going to pipe in cleanse data. We're going to remove, see this right here, replying, stores, store, and Safeway. So word not equals, and each one you do word not equals, word not equals, word not equals. You're going to anti-join in the stop words. We don't want the stop words in there, right? And then count the words with, right here, see this, word cloud, word, and max words equals 50. So the word is the actual word, like in this case, tears, or Trump, or I'm, or store, right? And then the N is the actual count of that. And then the max words is how many do we want to show, right? So in this case, let's run this. And now sometimes you'll see it gets cut off here and gets cut off here. It remembers the space for the positive and the negative parts. You need to get rid of that. So to do that, the best way is just do this, clean it, and then rerun it again. See that? Then it shows the whole top part and the bottom part. And you can see here by looking at it, obviously the words that are the highest up with the most instances will be largest, and those are the smallest instances will be the smallest. So you get Trump being a little bit bigger than Biden. We get grocery, heart, laugh out loud, quote. Now this is not necessarily negative and positive. It's just the top most positive words, or not most positive, most popular words. I'm sorry. Now, what happens when we want to go and do this? I want to go and see what I showed you at the beginning. I want to see the positives and the negatives, right? Kind of in a measured manner. So what we're going to do is we're going to use the same thing, but we're going to use library reshape 2, and we're going to use cleanse data, and we're going to pipe into that the 3 sentiment dictionaries from above. Remember we did that earlier on, AFIN, Bing, and NRC. Then we're going to bring in anti-joint stop words, count the word sentiment, sort equals true. Now the difference is we're also going to bring in this ACAST of the word sentiment value dot variance equals n and fill equals 0. And then we pipe that into comparison cloud, and we're going to use the colors. You could use any colors you want. In this case, I'm using red and blue. Red is negative, blue will be positive, okay? And the max words is 50. Now, what happens when we do this? Let's take this. Let's run that. Now, see, we're missing the top and the bottom again, remember? So we got to do this, yes, and then run it again. There we go. Now we have all of our words there. Now, in some cases, hell, some people might consider that a curse word. I didn't place that in there, but it's up to you. If you want to put that in your curse words list, and that wouldn't have showed here. Okay, and you can see from this there is more positive words than there is negative words. You can clearly look at seeing this, that probably, I don't know, 60-70%, maybe give or take a little bit, maybe a little more, is positive versus negative. Negative words are things like liar, tired, fear, and it shows them by size as to how often they appear. So obviously love, joy, and smiling show the most, and bad shows the most for a negative word. So we've got our negative, positive, but what if we want to also do it in a measured manner? I want to see exactly what is the percentage of positive to negative, right? So what we have to do is we got to take our cleansed data from our sentiments, and we want to count the sentiment, sort equals true, like we did before, and put it into sentiments. See how I put that into sentiments right here? Okay, so we do that. Then we bring that sentiments down here into these two rows, and we split them up for positive and negative. And we're going to put them into, we're going to subset them. That's how we're doing it, DPLYR. And up here you got sentiment positive and sentiment negative. So we're going to put the positive in the positive, the negative in the negative. That's exactly what we're doing here. It's all we're doing in that row. Then what we got to do is we've got to get the occurrences, right? So we need to aggregate. N is, remember, the number, right, for sentiment. Data equals sentiment positive. And then this one, data equals sentiment negative. So when we bring those guys in, we sum them. We put them in the correct one. So the positive goes in the positive score, the negative goes in the negative score. So we got positive underscore score and negative underscore score. Okay? Then it gets pretty simple. Once you get through that, all you're going to do is get a ratio based on the positive score, right, of the n variable, because that's where we put it in, right? The numeric number, and then of occurrences, and then the negative score of $n. That's how you, in a data frame, you access the variable or the column. So in this case, the column is n, and we're doing it for the negative score and the positive score. Once you do that, it puts that into the ratio positive and negative, and then all you've got to do is run this guy right here, just like this, and there's your score. Now, what that is right there is .87. You have to multiply it by 100. We all know you have to do that to get the what percentage, right? So in this case, you would have 87% positive, and what would that mean? You'd have the opposite of that, which would be 13% negative. That's where I told you we're probably looking at about 70, 60%, whatever difference, but now you have to lower it a little bit. So even though it says 87%, remember we removed what? Oh, we removed, well, the stop words don't normally matter, right? Because we're removing them and they're both positive and negative. Well, they're not either, they're nothing. But we added something to it. We added the curse words. Now the curse words, what? They're all pretty much negative, right? So if we remove the curse words, we're doing what? We're inflating the positive numbers and deflating the negative numbers. So what you would have to do is go back through this and just run it the same way, but without the curse words and the stop words, right? And then see what your number comes out to. I've already done that for you. It ends up being 78%. So the difference is basically 9% is the bias or skew that the curse words, by removing them, that we induced, so we have to take that into consideration. So even though here it says 87% is our positive negative score, well, think about it. If you didn't remove the negatives or the curse words, you really would be at 78%. So that's the true number here. So if you wanted to measure this and you wanted to say, okay, this is for this window of October 1st to October 12th. What if I wanted to look at it and compare it to the same thing in November 1st, November 12th? Well, all I'd have to do, or any time I could even compare it to the month of November. I would have to look at, because I'm just comparing percentages, right? In the end, I could do that, and then I could say, okay, it's 78% now. Once you take this the curse words into account, maybe in November it goes up and it's 80%. Well, we could say there's a 2% gain in the positive sentiment online in Twitter for this grocery store chain. And that, again, the data for this came from Twitter, and we used the replies for that period of time, and we scrubbed it or removed, things like comment, username, like labels like that. Just left the actual replies themselves to do this. And it's very interesting to do this. It's very enlightening. You can see all kinds of things. You see what the people are searching for. What's neat is that you can also help identify and get ahead of the curve on negative things. For instance, let's say a store has an issue with stuff being out of stock, or something worse. It could be anything. It could be a pothole out front. It could be construction going on that's blocking, making so people can't get to the store. You might be able to quickly identify something that you didn't know before. It could be anything. Okay, it could be just stuff people are talking about. Maybe there's a recall that affected people in a negative way. If you can if you can figure that out, this is what's cool about data science. If you can figure stuff like that out, you can get ahead of it and then try and fix it. Right? You get your marketing people, your marketing department, your directors and stuff can get ahead of it and try and figure out, okay, let's put a positive spin on this somehow, or let's go and do a giveaway, or let's do some coupons, or it could be anything, any kind of a marketing effort to try and turn around a negative. I hope you found this interesting. This is one of my favorite analyses to do, is sentiment analysis. Sometimes I call it sentimental analysis. It's really sentiment analysis. But I hope you found this interesting and enlightening and entertaining. It's really cool stuff when you get down to it. And think about it. The implications from this are huge. So there are bots that people have created. And, of course, the CIA and NSA have stolen some of that technology and that code and stuff. And they use that to take all of the phone calls people make inside the U.S., messaging, any kind of way that you communicate with people electronically. They store all of that, and they use that to go and predict things and to see if they can spot, bad things coming to fruition and stuff. People also have created bots to predict the stock market, and they use sentiment analysis to do that in those bots. They go and see, okay, what is the sentiment? The sentiment here is basically good for this, but this is not the whole economy. This is a grocery store chain. So you would want to look at a larger item or a larger niche, something like just the world in general, and just look at general, which is a lot. You'd have a lot of data there. And go through that and figure out what's negative and positive. And you can go from that, and actually a guy did really well. He created a bot, and during the last Great Recession, 2008, where most people lost like 50%, 52%, 40% of their monies at that point because of the drop in the stock market, he went up 684% at the same time frame. Why? He used sentiment analysis in a bot to go and predict where things were going, what he should be investing in, what he should be switching to. Well, I hope you found this interesting and educational. Please take a moment to subscribe, like, and share, and please try this out. Try this code. Try and make these things for yourself. It's pretty interesting what you can do. Thanks again, and have a great day.